Hi, everybody. Thanks for coming to our talk. So first, a brief introduction. My name is Faye, and I work for Alibaba Cloud as a product manager, mainly our data team working on analytical data infrastructure. And today, talking with me will be my engineering counterpart, who is the engineering head of our data warehouse, AnalyticDB. So we are going to cover today of how our teams are leveraging Ray, combining data plus AI to serve some of our top customers, and what we plan to do going forward. So now let's look at the relationship between data and AI, right? So coming from the data world, we're very familiar with this closed world. These data systems, they are closed world models. They have information for everything that's within enterprises. You have exact facts of your data. You can do precise queries of these data. You can also do real-time updates. For example, Alibaba Cloud AnalyticDB is our data warehouse, is a great example of these systems, and they're great at what they do. But they have a lot of shortcomings. For example, they were traditionally not so good at dealing with large amount of data, and also it's hard for them to process the vast amount of knowledge that's out there that's out of the enterprises. We also now have the open world, which is the AI. That's exemplified by the LLM trend that we have now. There are open world models. They know everything from the open world. For example, our open source model QN is one of these LLMs. So they have knowledges of compression. They have knowledge compression and summary. What they're good at is that they know general knowledge about the world. They are summarized and they know a lot. But they also have shortcomings because they only know you can only do fuzzy queries of them. They hallucinate, and you can only do periodic updates on them. And coming from the data world and serving a lot of data teams for our customer base, what we see is that the trend that data gravity continue to exist, meaning that it's still going to be important for customers to use their data in place, but having these open world AI models, it enables them to combine the closed world and the open world to generate more value. So we've been talking to a lot of data teams, and they've talked to us, discussed about how they want to bring AI to data because they have that gravity. They want to generate more value, and they want to use that open world to combine with their closed world. What that means is that traditionally in data warehouses, you store like your sales data, your customer data, your like data about logs. That's high value density, but it has a low volume. But now when you're going to combining the open world, meaning that you can extract value from low density data, like text, like images, the audio processing and video processing. And now you're going from mainly structured or semi-structured to a multi-modal world, right? So we're also seeing that our data warehouse users are trying to combine what they traditionally have in warehouses to these new data sources, like all the multi-modal data I've been talking about. But there are challenges, right? Going from these data warehouse paradigm to a multi-modal paradigms has many different issues. So first is that it's not just tables anymore, right? Now you're processing all these multi-modal data. The pipelines, the ETL pipelines, are going from like just maybe a simple SQL or simple Spark to heterogeneous data types. And traditional engines that deal with these data types are usually not as efficient. So for example, people are used to dealing with a structured data or semi-structured data with Spark, but now Spark is not as good, although it can process text, long text images, but it's just not as intuitive a paradigm to deal with multi-modal data because it has to fit in the structure of a data frame. And also, traditionally, data warehouses only utilizes CPU resources. But now, because we're going full multi-modal, we're dealing with a lot of multi-modal data. It's also important to them that they also need to leverage heterogeneous resources like GPU and CPU at the same time in a distributed computing environment. And also because we're now bringing AI to data, and traditional data system can only do data workloads, and you have to go to a complete new system for ML workflows, and they are very expert-oriented. So it's difficult for a lot of these data teams to understand how that works and to have a high learning curve. So it's also difficult for them. Combine these key challenges that we're seeing from our customers, and we're also seeing a drastic increase in how much customers are leveraging Ray as an open source technology on our cloud. So we decided to test and then go. Now we have gone full GA with our new product launch as part of our Alibaba Cloud proprietary data warehouse. So basically what we did is that just similar to how Lakehouse, when you're going from data warehouse to a data lakehouse, you're adding from your proprietary MPP services, adding on top of that your Spark services. We're now also adding fully managed Ray services. So now ADB has ADB is short for AnalyticDB. ADB provides a comprehensive platform for building and optimizing AI pipelines. So here is what it looks like. So what we would like to do by offering AnalyticDB Ray, our managed offering of Ray, so that we can unlock AI potential in our data warehouses. And the primary goal of this offering is to address the issues that I just talked about, to have seamless integration of multi-modal ETL. So we're going from a plain vanilla SQL-oriented structured ETL to a multi-modal ETL, and then combining that with AI workflows. So now you're going from a very traditional data warehouse to something that's very data plus AI combined. It also maintains that data gravity that our customers really care about, and make it easy for them to go from a simple data workload from data plus AI. So we're seeing adoption in many different interesting use cases, which me and Liang will start to talk about. So some of these use cases are inferences, multi-modal data processing, physical AI, especially for simulation, similar to what Jim Van talked about earlier, and also AI pipelines. So before going to the use cases, I will briefly touch upon how we're different from just managing open sources. Because the customer can manage Ray on Kubernetes, they can self-manage Ray on just ECS, but why would they need something like a fully managed Ray as part of our data warehouses? So there are a couple of reasons why you want to do that. Because our focus and our goal is on customers, as I mentioned, that's mainly from the data team. So they are not as familiar with AI infrastructures. So it's important for them to be able to do fine-grained resource scheduling to make sure that now they can make fully use of their GPUs. They also want to make sure that their cluster operations and maintenance are easy, is stable, is high available, because now they're using this new technology that they haven't been using before, Ray, and they want to make sure that's seamless for their customers as well. So what we did, our solution is enhanced in the following way. So it's a fully managed services. We have enhanced part of the Ray kernel so that we make it stable and performant, especially for long-running jobs, because we're doing many ETLs on Ray, so that's also very important to them. We also make sure that it's integrated with our existing offering, which is the Lakehouse, and make it production ready. So there are actually 4 enterprise enhancements that we did. So the first enhancement is that we made it easy for users to do auto elasticity on our managed version of Ray, so that when their large ETL jobs comes, it's a serverless behavior to them, so that we make sure that the precious GPU that they have a high utilization rate. So for some of our customers, we're seeing a very drastic increase, going from under 5% utilization to 40%. So the way how we're doing this, Liang will talk about later in his technical deep dives. So the first one is, so that's our first enhancement comparing to open source Ray. The second enhancement, what we did is that we offered a stream computing node. So basically, we are seeing that for a lot of our use cases, especially for large multi-modal multi-modal ETL large jobs, the bottleneck is in I/O, and that is preventing our customer getting the optimal performances. So we actually implemented a object storage to eliminate that bottleneck, and that helped us to increase the pipeline latency as well as the throughput. Also, so that's the second enhancement that we did comparing to open source. The third enhancement is we did a series of changes to improve in enterprise-grade stability and high availability, so that for failover uptime, it is better compared to open source, especially, as I mentioned, for large data ETL jobs that we see very common from some of our customers. And the last one is that we also have launched observability monitoring that doesn't come with open source, so that's easy for our customer to be managing that. So those are the 4 different enhancements that we did on our managed version of Ray comparing to open source. So after that, I'm going to talk about some of our use cases that we're seeing in the real world. So let's get started. So the first one is batch inference and data distillation. So as we see the foundation models start to gain popularity, we're seeing there are vendors in our customers that has specialized fine-tuning or specialized foundation model needs. So basically, they're training their own models. So for example, one of our customers, they have a very deep expertise in offering multi-modal foundation, so multi-modal large language capabilities. So that's kind of their focus. But even for multi-modal large model that's focused on video and audio, they still need a very strong text ability, because without understanding text, there's no way for you to generate a proper video. So their plan basically is to distill QN for the text part of their model, and then do proprietary work for the multi-modal part of their language model. So their challenge basically is to generate text samples from QN, and then use those samples combined with their multi-modal part of the training data to train their final model. So they are partnering with ADB Ray, where basically we're the central data warehouse to generate all their training data, and that includes distilling from QN, doing long text ETLs on top of that, and then afterwards feeding that into their training pipeline. So we were leveraging some of our enhanced capability in our Ray core. So for example, we use our cache acceleration capability to help them increase their input, and also using our elasticity to schedule all the jobs for the inference to prepare the data, to prepare for model distillation, and that can be a lot of tasks and also improve their GPU utilization. So finally, they were able to launch their multi-modal LM, and that's also pretty popular in the market. The second example that we're working on is with a series of robotics company, mainly in China. So what we found is It's very similar to what Jim Van said earlier in the morning, that a lot of these robotics companies, they're facing challenges generating data so that they can train their VLA models. And there's a further thing that we found talking to these robotics companies, especially companies who are mainly focused on the automation and the mechanical part of the stack of the robotics, that the situation of physical engineering, data engineering, is very similar to the state of machine learning engineering, maybe in the 2015, 2016 timeline, where engineering are just using basically using software, standalone software on their laptops. There's no collaboration. They're not utilizing central cloud resources. Also, they're not sharing data. They're not sharing experiments. So we see this area as a very interesting area for disruption and for change. So what we're doing is that we're working with some of these top robotics companies to help them, starting from simulation, but go all the way end to end on their physical AI workflow and pipeline, especially the data part of it. So we have a one-click version of ISAC Gym and ISAC Lab. We're also helping them going from that human capture of data combined with the simulation, and we combine all of their data set, do ETL on them, and get those data sets ready for reinforcement learning as well as their VLA afterwards. So that's what we have been doing on the robotics side of things. And all of these, since a lot of these robotic stacks run on Ray, so we're able to offer that ASAC Sim Lab on our managed version of Ray, and then combining with the enterprise enhancements I talked about earlier, this offers a whole AI simulation use case for our customers. So the third one is our AI pipeline optimization, which Liang will talk about later. I'll just touch upon it briefly. So we're working with the e-commerce platform to help them use reinforcement learning to use those clickstream data combined with machine learning to help them increase their ads performance. And all of that is also run on Ray, all the way from the data pipeline to the end of the AI pipeline. And the final use case, which Liang will also talk about later, is multi-data processing and distributed fine-tuning. So to recap, we offer a managed version of Ray with our enterprise enhancement with 4 different use cases: robotics, distillation, fine-tuning, and pipeline optimization. Now I'm going to hand it to Liang to talk about how we're doing that under the hood from the technical point of view.
Okay, now I have covered what and why of our Ray service. Now we are going to talk about how in the next 10 to 15 minutes, we are going to deep dive into the technical details, like what powered our Ray service. So the overall idea is the data plus AI architecture. As you can see from the slides, what we try to do here is to eliminate the silos between data storage, data analytics, and AI computation. And the whole architecture is anchored on this unified resource pool, which manages all our CPU and GPU resources. And this pool serves not just a SQL engine and a Spark for traditional SQL data processing workloads, but also like Spark and Ray for AI computation as well. And for data access, let's accelerate by our storage acceleration cluster, leveraging advanced technology like FPGA so that we can bring data to a place that is faster and more efficient to access. What tied all these systems together is our eRDMA memory pool. It's a remote memory pool, like all the components can access, and also Ray object store. And so from this, like all the object and all the data processing can be fly through entire in-memory across all the systems, across all the stages. So this is the architecture that enables us to build this simplified and one-stop AI plus data infrastructure for our customers. What different from What made us different from the open source Ray is we also made a few enhancements to make this more enterprise friendly, right? So including 4 pillars. One is usabilities, including one-click deployments and observabilities. We have our own console that provide more detailed analysis and metrics for customers to use and managing their Ray clusters. This help them like smoothly transition from prototype to production. Scalability is of course like non-negotiable, especially for enterprise customers. So we provide features like seamless migration. This is pretty important to migrate Ray tasks across machines in case of machine issues or data center maintenance, or we need to do loading upgrade. And also self-healing and high availabilities to make sure like if any of the node down, and then we can do failovers on either the head node or the worker node. And cost performance, we have virtual cluster. This is mainly for multi-tenancy, so that you don't need to bring down Ray cluster for a job. This is like one cluster continue running, but each tenant is seeing this as a virtual cluster for all the different tenants. We have auto-scaling and fine-grained schedulings that I will talk about detail later. Ecosystem is very important, and we are this service, of course, have tight integration with our data warehouse service, and we also connect to all different data lakes format, Iceberg, Lens, etc. for different kind of workloads. And we provide integrations with set of tools. Of course, like these days, people use different open source tools for their training and inferencing, right, like Llama Factory. So these are the key features like we provide to our customers to make this Ray service more like enterprise ready for our customers. So this is just a few of them, and later on I will zoom into some of our big customers' use cases and talk more about like 1 or 2 features, because there's not enough time to cover all of that. So the first one is multi-modal data processing. And you can see from these slides, this processing pipeline is very common for our customers, like in automotive or robotic companies. They have clips coming in like from file ingestion to decoding, transcoding, embedding, and whatever. So it's a long pipeline. Usually, I only have like less than 10 nodes here, but usually like for these companies, like one Ray process pipeline is usually 20 to 30 tasks. So this entire thing is orchestrated in the Ray cluster, and we have workflow management system that can process, like it's used to schedule this Ray job for like millions of incoming clips or task files. So let's zoom into some of the features we use in this pipeline. And the first one is adaptive streaming pipeline. And this is the operational key which it's possible to do high throughput processing. And the main idea here is to eliminate the resource idle time between CPU and GPU here. And as you can, so for all the processing, right? So when CPU start processing, when CPU finish processing part of data, and then GPU like instantly start like working on that, and simultaneously CPU start moving to the next batch of the data. So this pipeline execution enable us to keeping both CPU and the GPU fully saturated. So there's no idle waiting times in between, as you can see from the left bottom side. And so all the data is streaming through in memory. So, and also together with the streaming pipeline is our load-aware autoscaler, so that we can keep like we can scale enough CPUs like to make sure we have enough data and workload streaming to the GPU to make sure that GPU is fully utilized. And so this, the data here is from one of our customers. Like they are doing processing of the clips. It's about 4 million clips a day. If you like remember earlier, like it's about 30 different actions for each clip. So it's like 100 millions of tasks per day. And at the peak time, it's like 80,000 clips coming in per second. So these are in their previous pipelines not able to scale and able to handle such high volume, and this streaming pipeline is able to make us to support this kind of high throughput processing. The other key pillar for performance is, of course, cost efficiency. We did this through advanced scheduling here, and by doing profiling, we are able to understand the footprint of each array task, right? So then we're able to increase the task deployment densities on each node. This can be done beforehand because we know the history of each job. This also can be done through live migration, as I have mentioned. And we are able to do live migration from for those array nodes to different machines without impacting customers' live processing. So by co-scheduling different tasks or various tasks on the same node, this is not just like different tasks on GPU, but also like different tasks on both CPU and the GPUs on the same node. And here, like we can, like for example, later, when GPU is processing the data, and we can like the CPU on the same node can start already working on the next, preparing for the next batch of data. So this kind of co-scheduling also help us to maximize the task throughput. So now for the AI-related workloads, the size of our cluster is already more than 1 million CPUs, like just to make sure we have enough data flow through for the underlying GPU computations. And we also have elastic capacity of 500,000 cores per day because like customer have like peak, right, for the incoming traffic. And complementing to that is the startup acceleration. Because elasticity is useless if scaling takes minutes. And so we have two levels of cache. One is the pod cache. From this, leveraging this, like we can, the node startup time can be done in less than 1 second. And the second level of cache is for Python workloads, we have built-in Conda environments, Python Conda environments. So by leveraging this, our Python task start time is like 5 to 10 milliseconds. So this kind of makes sure enable us to, like, when the autoscaler calls, the task is almost ready instantaneously. So this made all the startup and processing and all the auto-scaling possible, like made all the previous streaming pipeline possible, right? So there's no waiting time in between. So we talk about multi-modal data processing, and the other two is talk about the other two very interesting use case. One is click-through rate prediction. This is very common for e-commerce platform. This is one of our customers' pipeline. So this kind of offline batch inferencing require massive data processing, like millions or billions of data points here to like do kind of ETL processing to go through all the data, and also text processing to understand the reviews, right? Then generate a prediction, but based on that. And because of this massive data processing, it's very heavy, right? So it's often lag behind and leaving the expensive GPU resources waiting. before moving to our platform, the GPU utilization for this customer is about 5%. A majority time is spent like waiting on CPU to finish processing and preparing for the data, right? So when after moving to our platform, we are able to scale the CPU part, like to make sure, like as we have mentioned, like we have low base auto scaling, so that we can make sure GPU is continue fed by by the CPU, and the CPU is continue processing, and we have enough CPU ready to make sure like GPU is continue keeping up with the data is fully utilized. And by doing that, and the GPU utilization rate is increased to 80%. The other part is like all the data is flow through the Ray object store and our ERDMA remote memory pool. So this also help with like there's no heavy data movements in between, and overall like the performance improved by 2 to 3 times. So this is so like every day customer can do more iterations, right? They can see like when they send out intensive to these customers, like what they behave. So this, by running this pipeline faster, it allow them to do more iterations and making more profitable, right? So for those customers. The last use case is game assistant. This is in the gaming company. So another interesting example is it's also multi-modal processing, and the use case here is that this game assistant, the company tried to build a model to understand the characters, objects, environmental context in the game, right? Like take a screenshot of the game, then they try to understand, then they will give actionable advice to the players. So this requires lots of processing and also fine-tuning. You need to keep the model up to date and relevant to the context, because game are getting upgraded, and the model also need to be continual fine-tuned to understand the context so that it can give actionable advice to the player. And previously, they were doing this on a single machine. Of course, this is not scalable, and they tried to looking for distributed solutions, but the stability is not that ready. So sometimes, like the pipeline can crash, or like the server itself is not stable to do servings for these models. What we provide to them is like a Ray-based platform for both fine-tuning and serving. So by leveraging this platform, the customer can do massive data fine-tunings to keep their models up to date and relevant. So this kind of give them a competition advantages to other players in the market. So the performance improvement here is about like 3 to 5x. But more important is like by doing distributed, it's more faster, and also through our service, it's more stable to able to serve all their service, both for fine-tuning and also serving online traffic. It's the model serving part. Okay, so this concludes our task. So this is how we leverage Ray as part of Data Plus AI platform to help customers to build their enterprise service. Right? So I'm only able to touch like 2 to 3 key features, but I'm happy to take any questions. Okay, that's a good question. So the question is there a tighter integration between Ray and our data warehouse? Yeah, there's 2 levels of integration. One is at the data access, like previously, like for other assets to data warehouse, you go through SQL layers. But here, like we can directly touch the data layer, and so the access is more efficient, so you don't need to go through all the interpretation of all the SQL engines. You can just read the data. So the other part is metadata. So for all the execution engines, not just Ray, but also Spark, like all the service we integrate in our service, and all the service on the Alibaba Cloud is able, where you can see the metadata across all these different products on different platforms. So this kind of made the user easier to get started. Sure, okay. Thank you, everyone.